Okay. So here's the homework problem. Please listen. We're looking for molar concentration. Since we're looking for molar concentration, then when we get an answer, the answer needs to be in moles of solute. That's an E, not an I. Moles of solute over liters of solution. Okay? Now, of course, that's the symbol we use for molarity or molar concentration. That capital M with a line under it. And the category I told you about yesterday, the category that molar concentration fits into is one in which you have some amount of solute divided by some amount of solution. Okay? All right, and you got your homework. We exchange paper, so have somebody exchange with you real quickly, and let's get started grading this. Okay? All right. Now, since the category is amount of solute over amount of solution, then we're going to take whatever amount of solute is in the problem in whatever units of measurement that are there and put it over whatever amount of the solution in whatever units are there and start with that fraction and then build our conversions. Okay? So the amount of solute that's listed in the problem is 2.37 grams of sodium sulfate. And that's going to go over whatever amount of solution there is. The amount of solution is 250.0 milliliters of this same solution. Now, the reason I haven't written the formulas yet is because we need to figure out what the formula should be to make sure we have the right formula. So, since we have sodium sulfate, the ATE ending is a clue that you've got a polyatomic ion. If there's a polyatomic ion in the formula, then you have an ionic compound. So you need to know the charge then on sodium and the charge on the sulfate ion. So the sulfate ion is SO42 negative, and this is your test references. You're supposed to have a copy of this. Everybody has one. SO42 negative is the formula for sulfate. The formula for sodium is found on the periodic table, but if you want to find the charge, you can look on the periodic table with oxidation numbers, also in your test references, and there's a 1+ charge on a sodium right there above my thumb. We want to put together a particle then that has a 1+ charge, and put that together with a particle that has a 2 negative charge. I don't know why I did it that way. 1+, 2 negative. But we need to have enough of each kind of particle so we get a 0 charge when we're done. So I need 2 of these and 1 of these. That means I need 2 of these sodium particles that have the 1+ charges and 1 of the sulfate particles. So our formula comes out to be Na2SO4. Okay, so this is the formula we're going to put here, grams of Na2, sodium sulfate, Na2SO4. And in the milliliters of aqueous solution, this is a Na2SO4 solution. All right, so that's how we start it. Whatever amount of solute we have in the problem over whatever amount of solution we have in the problem. You identify the solution by the solute. You don't have to name what the solvent is unless it's something other than water. You just don't say a solution of sodium sulfate in water because water is used so much. We assume it's water unless you say otherwise. So now we're ready to convert the top part of this into moles and the bottom part of this into liters. So to go from grams of something to moles of something, I need the molar mass. So we're going to calculate molar mass for this compound. So we've got sodium and sulfur and oxygen in this compound. We go to the regular periodic table and find the atomic masses for these elements. Sodium, right here above my thumb, is 22.989769. Sulfur is 32.065. And oxygen is 15.9994. And we need to multiply these masses by the number we have in the formula. The actual definition of molar mass is the sum of all the atomic masses of all the atoms in a formula. Well, the sum, we can do multiplication to make it a little bit faster. So times 2. So 22.989769 times 2. I should have left myself a little more space over here. I don't want to have to bunch it up too much. 45.979. We'll answer the phone. Oh. Hey. Good. Yes, ma'am. Okay, sure. D104, sure. Okay. All right, sure. Carissa, Ms. Donna Mays needs to see you. She's in B104, but not right this minute. Just between classes and as soon as you can, okay? All right, so the answer here is 45.979538. And in the formula, we only have one sulfur, so that's just times 1. We'll put the same number over here, 32.065. And then oxygen is times 4. So 15.9994 times 4, 63.9988. All right, I wish I'd written it a little bit larger, but hopefully you can see you've got 3 empty slots here. 1 here and 2 on the far end on the right. But we want to add all these numbers together now. So 63.9988 plus 32.065 plus 45, what?
Why don't you go down?
I don't know. Does it matter? That's right, doesn't matter. 45.979538. And we have an answer of 142.04338. Okay? And because I have 3 empty slots on the right in those columns, I need to round off 3 digits. And you get 142.043. And you have to write the complete answer that's required in this class. That's grams of Na2SO4. And the complete answer includes saying that's equal to 1 mole of Na2SO4. All right. This equality statement is used then to build a conversion unit. So up here in our problem that we're building, we want to put the side of the equality statement that has the same starting units and species here on the bottom here. You raise your hand. Okay. So we want to put this on the bottom, 142.043 grams Na2SO4. And on the top we want to put the 1 mole Na2SO4.
Although from the bottom of that statement, you just said I had 142.042.
Okay. Can you tell what you did Or did I do something different? Did I do?
Mister. Yeah. For ocean, I got 63.9976.
Yeah, you did 15.9997 times 4.
Oh, did I? Okay. Well, let's fix that then. Oh, you're right. I punched the wrong number there, didn't I? Right above the 4. Got to watch out for that. Okay. So 15.9994 times 4 is that number. So now I need to add these numbers together again, right? Why don't you tell me that sooner? Golly. Okay. So it should be 142.42138.
Yeah.
Okay, which then gives us 142.042 then. Is that correct? All right, I'm just going to change it right here. And up here I'm going to go 142.042138. Yeah. When I'm showing you the answers a lot of times, I don't have time to do the answers twice in my calculator. It helps when you guys tell me if I punch a button wrong. You really should, but the illustration is good because it points out that everybody should double check your math. Do your math at least twice in the calculator, make sure it's right, okay? Even I punch wrong buttons sometimes. All right, so we need 142 up here, 042 up here on the end, all right? Now, what this allows us to do, though, is to cancel grams, cancel this species, like you cancel x's and y's in algebra. And we have moles of Na2SO4 on the top, and that's the solute. That's what we're trying to get, moles of the solute on the top. Now on the bottom, right now we have milliliters, but we want it to be in liters. So we need a way of converting from liters to milliliters. And for that you need an equality statement, just like we have an equality statement down here at the bottom of our molar mass calculation. The equality statement that, somebody got a question? The equality statement that gets you from milliliters to liters is 1,000 milliliters equals 1 liter. Now you need to make sure that's written down. It's required in this class. You always write your equality statements. Since I've got milliliters in the bottom here, to cancel milliliters, I need them on the top here. 1,000 milliliters, and I put the 1 liter on the bottom. So let's see, let's cancel out milliliters. And in doing so, then I have liters of the solution on the bottom, and that's what I want to get this molarity. Okay? So we're ready now to do the math. All right? You can plug it in your calculator to get the math. And the way I've taught you to do this, the way that I think is faster to do it, is to take what's right here, 2.37, and multiply times 1,000, and hit enter. Then divide each of the things on the bottom separately. So I just hit the divide key and automatically puts in the previous answer. 250.0, enter. Then divide by this separately. So I divide by, and you see it's put the previous answer up there. Divide by 142.042, enter. Now we need to figure out how many significant digits we want, or need. We're going to look at all the measured or calculated numbers. This is measured, that's calculated. And of those numbers and only those numbers, we choose the one with the least digits, that's this one, and write our final answer to have the same number of digits. Remember, leading zeros like these two zeros are not significant. So our first significant digit is this 6. 1, 2, 3 significant digits. Underline everything else. We need to write out the units we have left now in the problem, and right now we have moles of Na2SO4 over liters of Na2SO4 solution. Okay, I want to reiterate something I said yesterday, that Na2SO4 is not the same thing as Na2SO4 solution, so you can't cancel these. Okay? These don't cancel out, but now we're ready to round off, and by doing it this way, we can see that we can write moles of the solid over liters of solution, we can simply write M instead of all of this in a fraction. So we want 0.0667. M with a line under it gives us moles per liter. We just simply need to identify the solution. It's molar Na2SO4 solution. And we can put a box around that to show us the complete answer, or the final answer, okay? Everybody got that? All right then, let's figure out how we're going to divide up the points here. I'm going to stop capturing here because the people at home don't even know that.